Okay, this is the 3.15 to 3.16 quiz. Uh, uh, why I'm recording this one before the others is because honestly I find this harder than the other ones. Uh, because the other ones we had them in the AMS, so like this is the new one. I will do the rest later. But yeah, I thought I'd do this one first because it's a bit hard. Okay, this first question, the first question it's just memorizing. يعني this is to measure gravitational acceleration. Just memorize this one. Uh, question two. Okay, before we continue, I'm gonna show you the formulas. The first one is the force between two objects. Cause like, look, whenever you have two objects in space, A and B, okay, there's always a force in between them. This is what we call the gravitational force. To find this force, it's G times m1 times m2 over r squared. Okay, G is a constant. It's always given. It's given. M1 and M2 are both masses in kilograms, and R squared is the distance, and it has to be in meters. Okay, it has to be in meters all the time. If it's not meters, which it's yeah, it's in kilometers in one of the questions, I'll show you what to do, but until we reach that question. But right now, in this question, it's meters. Okay, one more formula is to calculate G, small g this time, not big G. G is the gravitational acceleration. To find G, it's big G times m over r squared. Okay, same thing. G is a constant, big G is a constant, m is the mass in kilograms, and r squared must be the distance. Okay, for here we have the distance between the Earth and the Sun is 1.48 times 1011. The mass of the Earth is 5.97 times 1024, and the mass of the Sun is 1.99 times 1030. Use big G is 6.67 times 1011, negative 11. Uh, what is the gravitational attraction? When they say gravitational attraction, they're asking for the force of gravity. So we do F equals G times M1 times M2 over R squared. So in this case, it's going to be G. So it's going to be 6.67 times 10 minus 11 because that's G times M1, the first mass, the sun, which is, that's not the mass, sorry, that's the distance. The mass here, uh, 5.97 times 10 to the power of 24 times the other mass, 1.99 times 10 to the power of 30 all over the distance between them squared. So 1.4 r is the distance here. 1.48 times 10 power 11 squared. You do this on a calculator and you're gonna get this answer over here. Okay, uh, that's it. It's just calculations. It's a long formula. And then part B, the acceleration of the Earth due to interaction with the Sun. To find acceleration is G equals big G times m over r squared. So you're gonna tell me we have two masses. Which mass do I use? You when looking for acceleration, you always look at the bigger mass, okay? The bigger mass because that's the planet that's going to be attracting it. So in this case, when we have Earth and Sun, you have to look at which one's bigger, and obviously the Sun's bigger, so use the Sun's mass. So G equals big G is 6.67 times 10 power negative 11 times the mass of the Sun 1.99 times 10 power 30 over the distance between them squared. So 1.48 times 1011 squared, and you should get this answer over here. Okay, the International Space Station is orbiting the Earth at a height of 408 kilometers above the surface. Take the mass of Earth as 5.97 times 10 to the power of 24, and take the radius of the Earth 6371 kilometers, and G equals 6.67 times 10 to the power negative 11, whatever. Okay, part A, the force that keeps the space station in orbit is its weight. Obviously, it's the weight. So I don't think I have to explain part A. It's the weight, yani. It's obvious. Because it's in orbit in space, so it's the weight that's pulling it towards the Earth. Part B, the acceleration of the ISS. Okay, acceleration is G equals big G times m over r squared. طب I told you, let's substitute first. Okay, big G is 6.67 times 10 power negative 11. The mass is 5.97 times 10 to the power of 24 over the distance. Okay, the distance is the important part. Okay, أول شيء it has to be in meters. Here it was kilometers. أول شيء you have to find the total distance, yeah? Because you have first the Earth, and the radius of that is 6371, which is given. And then you have the height, so the satellite's up here, which is another 408. So to find the total R, it equals 6371 plus 408, which is 6779. So that's your total R. So over 6779 squared. But here's an important step. This R is in kilometers, but so we need this R to always be in meters. But the rule is if R is in km, multiply by 10 power 6 in denominator. Why you have to do this? If I tell you why, I think I'm gonna confuse you, okay? But always do this because it has to be in meters. So you're gonna put times 10 power 6. Okay? Put this in a calculator and you're gonna get 8.67. So your G equals 8.67. Okay? Then for part II, the mass of the space station is 4.2 times 10 power 5. They want the weight. Weight equals mass times G. The mass is, so W equals 4.2 times 10 power 5 because the mass is 4.2 times 10 power 5. And the G we found it in the previous part, which is 8.67. And again, put this in a calculator, you get this. Okay, every two particles in the universe attract each other with a force that's directly proportional to the product of their masses, because remember, force equals m1, m2, obviously have the big G on the side, over r squared. So the product of their masses directly proportional and inversely proportional to the square of the distance between them. Okay, that's why. It's always the square. And then we have rules, okay? Let's say F equals G m1 m2 over r squared. That's 2 should be up, my fault. R squared. فأنت you have to see, they say sometimes what if m1 is doubled? It's simple. If the numerator is doubled, then the force is doubled. If numerator is doubled, then force is doubled. طب then you're gonna ask me, what about the denominator? هلا the denominator doubled, the force won't be halved. No, it won't be halved. The force will be divided by the square. فأنا what do I mean when I say divided by the square? Like look, مثلا let's say R was doubled. That means times 2, right? And the denominator it was times 2. But since we're squaring, you have to do times 2 squared in the denominator. So it's going to be times 4. So you're going to be dividing by 4 now. So the force will be divided by 4, if you get what I mean. So let me show you here. The distance R is doubled, times 2 squared. You get times 4, and it's in the denominator, so you're going to be dividing by 4. So that means it's a quarter. You know, over 4 is quarter. Both masses are doubled, so that means times 2 times 2. That means times 4, quadruple. Both masses are doubled and the distance is doubled. Both masses are doubled, that means times 2 in the numerator. And the distance is doubled, that means times 2 squared in the denominator. So you get 4 over 4 equals 1, so nothing changed. Okay? Here it's the same question. They're saying the gravitational force between two masses and d meters is F newtons. They're saying, what if the distance was doubled, 2 by 2? What will happen to the force? I told you, distance doubled, so times 2 squared becomes times 4 in the denominator. So 1 over 4, which is 0.25 quarter. Okay? هلا I'll post the rest of the recordings in a bit.